All right, friends, so this is a video covering what we did on Tuesday, March 28th. This is the packet, the stoichiometry packet on BCA tables, the very first one that we got. If you were absent on this day, or if you just need a refresher, need to see the instructions again, or just check your work, whatever, this is a great video for you to watch. I'm going to start at the beginning and just work through the entire packet. Okay, so this is the introduction to stoichiometry. Stoichiometry is our next topic that we're going to be covering for the next 2 to 3 weeks. And stoichiometry is when we use balanced chemical equations to predict how much product can be made from a certain amount of reactant. So the way that I introduced this in class was I said, okay, think about like if you're making a recipe. A balanced chemical equation is kind of like a recipe because it tells you what ingredients you need or what reactants you need. And it also tells you how much product you're going to make from that amount of reactant. And there are a lot of similarities between thinking about recipes and cooking and thinking about balanced chemical equations and working in a lab anytime you're doing a kind of chemical reaction. So because there are so many similarities, we're actually going to start our study of stoichiometry. We're going to start it with food and recipes. So we're going to start with grilled cheese sandwiches here. It's telling us that to make a grilled cheese sandwich, we need 2 slices of bread and 1 slice of cheese. Now, I know that there are other ways to make a grilled cheese sandwich, but we're just going to stick with this recipe. And if it doesn't follow the recipe, then we're not going to count it as a sandwich. So if we have 2 slices of bread and 1 slice of cheese, of course we can make 1 sandwich. And if we have double that amount of ingredients, if we have 4 bread slices and 2 cheese slices, then we have enough ingredients to make 2 sandwiches. Well, here's where it gets a little bit more interesting because now we have 3 bread slices and 3 cheese slices. We have enough cheese to make 3 sandwiches, but we don't have enough bread. We only have 3 slices of bread, and we can actually only make 1 sandwich here. We can only make 1 sandwich because we don't have that 4th slice of bread that we would need to make the second sandwich. And we definitely can't make 3 sandwiches. So the reason we can't make 3 sandwiches is because we don't have enough bread. Let's look at this last example here where we have 6 bread slices and 2 cheese slices. Well, now we have enough bread to make 3 sandwiches. But do we have enough cheese? No, we don't. We only have 2 cheese slices. We would need 3 slices of cheese in order to make the 3rd sandwich. So we can only make 2 sandwiches here. Like I said, there are a lot of similarities between cooking with recipes and following chemical equations. So we can actually write this recipe in the form of a chemical equation, and here's how we do that. We're going to say 2b for 2 slices of bread plus 1 CH, that's a slice of cheese, and an arrow, which represents yields or makes, produces 1 sandwich. So 2b, 1 CH yields 1 sandwich. And then it asks, what is a limiting ingredient? A limiting ingredient, what it means by that is it is the ingredient that you run out of first. So it's the ingredient that is limiting how much product you can make. So in this example where we had the 3 of each bread and cheese, the limiting ingredient there is going to be your bread because you run out of bread. And the bread is what's limiting you to only 1 sandwich. If you had more bread, then you could make more sandwiches. But in this example, where you have 6 slices of bread and 2 cheese slices, well, now the cheese is your limiting ingredient because it's limiting you from making that third sandwich that you would be able to if you had more cheese. Okay, so the recipe for the grilled cheese sandwich is easy enough that we can just kind of do it in our head, right? We can figure out how much of this we're going to be able to make and how much of that we're going to be able to make, how much of this we need, blah, 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 because it's a very simple recipe. But some recipes, like some chemical equations, are more complicated than that. And there's bigger numbers, there's more numbers to keep track of. And when we have more numbers and bigger numbers, we need a way to keep track of all that information. And that's where the BCA table comes in. This is a tool that we're going to use to keep track of all of the ingredients, all the reactants, all the products that we have in our recipes or in our chemical equations. And the first step of using a BCA table is to write the recipe as a chemical equation. And here's how I want to do that. So I'm going to read my recipe. We have 1 crust, 3 ounces of sauce, and 2 cups of cheese to make 1 pizza. And I'm going to write those ingredients as a chemical equation. So say 1Cr. I'm not doing this on the lines, I'm doing it above the line. There should really be another space right here. It says equation. 1 crust, 3 ounces of sauce, plus 2 cups of cheese yields 1 pizza. Now the scenario that we're in here is we have 5 crusts, 12 ounces of sauce, and 100 cups of cheese. And we want to figure out how many pizzas can we make from that. Let's talk about what these rows mean. Or we'll start with the before row. This means before cooking. Or later when we start applying this to chemical reactions, before the reaction occurs. So we just have like a pile of ingredients or a pile of reactants, and it hasn't been cooked yet. It hasn't been prepared into pizza. So before cooking anything, that's where we have this pile of ingredients. So I'm going to put 5Cr right there. 12 ounces of sauce and 100 cups of cheese. That's what we start with. What number goes right here? Now maybe you have an answer in your head already, but this is actually 0, because remember, this is before cooking. Before we've done anything, we don't have any pizza. We haven't made it yet because we still have a pile of ingredients. Now we need to figure out how many times we can make this recipe with the ingredients that we have. And here's how we do that. We're going to take all of the numbers on these blanks, and we're going to divide them by the numbers right above them. So I'm going to say 5 divided by 1 equals 5. 12 divided by 3 equals 4. And 100 divided by 2 equals 50. Okay, that's the next step. The step after that is to pick the smallest of those numbers. So between 5, 4, and 50, 4 is the smallest number. And I'm going to take that 4 and I'm going to pull it up here in front of the chemical equation that I wrote. I'm going to put the chemical equation in parentheses like that. That 4 represents me making the recipe 4 times. So I'm going to make the recipe 4 times. I'm going to do that 4 times. And if I'm going to do that, if I'm going to do the recipe 4 times, then how many crusts am I going to use? I'm going to use 4, because each time I do the recipe, I use 1 crust. So if I run it 4 times, if I make the recipe 4 times, that's going to be minus 4 crusts right there. How much sauce am I going to use? I'm going to use 12 ounces of sauce. And I'm going to use 8 cups of cheese. The reason that these are minuses is because, remember, those are being used up, right? So this is before and this is the change. And later we'll do after. So it's going to be 5 minus 4, 1 crust left, right? But we'll get there in a sec. Okay, over here I'm going to write plus 4p. because I'm making 4 pizzas. That's not going to be a minus over here on the product side. It's going to be a plus because I'm making product. There we go. What I was doing there, the way that I was getting those numbers is by taking that 4 and distributing it, like I'm in math class, distributing it to each of my coefficients in my chemical equation or in my recipe. That's where the change row comes from. The change row comes from distributing your smallest number, distributing it to each of the coefficients, multiplying it. Okay, now I can do my subtraction. This is 1 crust left over, 0 ounces of sauce left over, and I'm gonna have 92 cups of cheese left. 0 plus 4 is 4. 4 pizzas. My instructions here say to circle what's left over, so I'm going to circle my 1 crust that's left over and my 92 cups of cheese. And it says box the number of pizzas we made. There we go, 4 pizzas. And that is number 1. I'm going to continue this later because my voice is killing me. I talked so much today. Okay, I'll talk to you later. All right, for the second one, why don't you give it a shot? Pause the video here, and you can try to figure it out, and then you can play and make sure that you got it right. All right, so let's start by writing our recipe as a chemical equation. On this one, we're making a bike. In order to make a bike, we need 1 frame, so I'm going to write 1 frame plus 2 wheels. I need 1 gear chain, GC, and 1 handlebar, all to make 1 bike. And then in my before, remember I'm going to put in my starting, the number of ingredients or parts, bike parts, that I have before I start assembling any bikes. So I start with 50 gear chains, write that over here, 52 wheels, 75 handlebars, and 30 frames. Before I start assembling any bikes, I don't have any bikes. I haven't made any yet, so that's going to be a 0 over there. Then remember the next step is to divide. So I'm going to divide my number down here by the number up here. So 30 divided by 1 gives me 30. 52 divided by 2 gives me 26. 50 divided by 1 gives me 50. 75 divided by 1 gives me 75. Now I'm going to take the smallest number of these. I'm going to take 26, and I'm going to pull it up here. Put the whole thing in parentheses, and that tells me, this 26 is telling me that I'm going to make the recipe 26 times. And then I can use that 26 to fill out my change row, because my change row shows us what our starting material is going to change by. If I'm going to make this recipe 26 times, I'm going to need to use 26 frames, because 26 times 1 is 26. 26 times 2 is 52, so I'm going to use all 52 wheels that I start with. I'm only going to need to use 26 of my gear chains and 26 of my handlebars, because those coefficients are just 1 and 1. I end up making 26 bikes here. And now it's just subtracting and adding. I got 4 frames left, no wheels left, 24 gear chains, and 49 handlebars left. I've also made 26 bikes. And there we go. That's the answer. Number 3, again, give this one a shot first. Pause the video now. And here we go. So I'm going to take my recipe, and then 1 hamburger bun, 1 patty, 1 slice of cheese, makes 1 cheeseburger. So I'm going to write 1 hamburger bun plus 1 patty plus 1 slice of cheese yields 1 cheeseburger. Just like that. And then I'm going to put in these numbers, these starting materials, in my before row. This is before I've made any cheeseburgers. So I start with 8 hamburger buns. I start with 16 patties. I start with 22 slices of cheese. And I start with 0 cheeseburgers because I haven't made any yet. Great. Division is my next step. It's going to be 8 divided by 1, 16 divided by 1, 22 divided by 1, and 0. Sorry, actually, you don't need to divide on your product side. Only the reactants, that's where you divide. I'm not going to bother writing it because it's all 1, so each one's just going to give me itself. The smallest number of those is 8, so I'm going to pull my 8 up here in front of my chemical equation, and that's showing me that I'm going to make this recipe 8 times. So then that is 8 times 1 is 8 hamburger buns spent, 8 patties spent, 8 slices of cheese spent, and I'm making 8 cheeseburgers. Then I do my subtraction here. To figure out what I have left. And my leftover ingredients are 14 slices of cheese and 8 patties. I also have made 8 cheeseburgers. And there we go. Number 4, you can do yourself. I'm not going to explain this one in the interest of time. I want to keep this video short. But I will show the answer, so I'll write it in, I guess. All right, now limiting reactants. So before we were talking about limiting ingredients, and now we can start talking about limiting reactants. We're going to take the exact same process, but apply it to actual chemical equations rather than recipes. But all the steps stay exactly the same. So this is our balanced chemical equation for the synthesis of ammonia. We take 1 molecule of nitrogen and 3 molecules of hydrogen to make 2 molecules of ammonia. That's the balanced chemical equation that we talked about before the break. But it's telling us that now we have 5 molecules of nitrogen reacting with 3 molecules of hydrogen. So imagine that you, I don't know, put those molecules inside a box. And you like shake the box around, right? Before the reaction happens, before you start shaking the box around, you have 5 molecules of nitrogen in there. 5 molecule nitrogen. MC means molecule. I want you to write that in. And we have 3 molecules of hydrogen. That's what we're starting with. This should be a 0 because we don't have any molecules of ammonia made yet. So remember, this is before the reaction occurs. Okay, and then our next step, just like before, was division. So I'm going to do 5 divided by 1 to give me 5, and 3 divided by 3 to give me 1. Take the smaller number and pull it out in front of the chemical equation. That shows us how many times we're going to run this reaction, how many times we're going to make the recipe. If I'm going to make this recipe only 1 time, then I'm just going to distribute that 1 to each of my coefficients. So 1 times 1, I'm only going to use 1 molecule of nitrogen because I'm only making the recipe 1 time. But I'm going to use all 3 molecules of hydrogen. What do you think this number should be? It should be a 2. It should be plus 2. I'm making 2 molecules of ammonia here because I'm running the reaction. I'm making the recipe one time, but this recipe makes 2 ammonia molecules. So if I'm doing the recipe once, I'm going to make 2. Okay, now I just do my subtraction and addition. I'm going to have 4 molecules of nitrogen left over. No hydrogen left over. And I'm going to make 2 molecules of NH3. There we go. Number 2, try this one yourself. Pause the video now, and then you can play after you finished. Okay, so this time we have 8 molecules of hydrogen. So I'm going to put that right here, 8 molecules of hydrogen, and 3 molecules of oxygen, O2, to form water molecules. But before the reaction occurs, we don't have any water molecules, so there should be 0 molecules of H2O. Do our division. That gives me 4 and 3. 3 is a smaller number, so that's what I'm going to pull out in front of my chemical equation to tell us how many times to run the reaction. 3 times 2 is 6 molecules of hydrogen. 3 times 1, I'm going to use 3 molecules of oxygen if I run the reaction 3 times. And I'm going to make 6 molecules of hydrogen. Sorry, 6 molecules of water. Now I do my subtraction and my addition. And there we go. I have 2 molecules of hydrogen left over, and I've made 6 molecules of water. Instead of circling the what's left over, this says to label the limiting and excess reactants. So I should have done that on the last one, but I'll do it now. Label the limiting and excess reactant. The limiting reactant, just like the limiting ingredient, is the thing that runs out first. It's the thing that's limiting how much product we can make. That's always going to be the thing that turns to 0, the things that we have none left at the end. That's the limiting reactant. The excess reactant is the other reactant. Excess means extra or leftover. So I can say that hydrogen is my excess reactant. And this is a way that I abbreviate excess. Get it? Excess. Cool. Box and number of water molecules produced. There we go. Five atoms of phosphorus react with 5 molecules of oxygen to make diphosphorus pentoxide. Label the limiting and excess reactants and box the number of diphosphorus pentoxide molecules produced. Why don't you pause the video here and try this one yourself. All right, so I'm going to start with 5 atoms of phosphorus. I put an A this time instead of MC because I'm dealing with atoms, not molecules. 5 atoms of phosphorus and 5 molecules of oxygen to make diphosphorus pentoxide. But before the reaction occurs, remember this is before the reaction occurs, I haven't made any diphosphorus pentoxide, so 0 molecules of P2O5. Then I do my division. 5 divided by 4 gives me 1.25. 1.25 is fine, keep the decimal, that's totally okay. And then 5 divided by 5 gives me 1. 1 is a smaller number here, so I'm going to use my 1 and put it out in front of my chemical equation. Please don't skip that step, by the way. If you haven't been writing it, you're going to get confused later on. I need you to write that number out there. Put it up there. Don't try to remember that it's up there. Write it. You have unlimited lead. So we have running this reaction 1 time. We're going to spend 4 atoms of phosphorus to do that. And we're going to spend 5 molecules, all 5 molecules of oxygen in order to do that. I'm going to make 2 molecules of P2O5 because that's how many I get from running the reaction 1 time. So then I do my subtraction here. figure out that at the end I have 1 atom of phosphorus left over and 2 molecules of diphosphorus pentoxide made. My limiting reactant is oxygen, because that's what I ran out of first, which means that my phosphorus must be my excess reactant. There we go. Number 4, again, give this one a shot. You don't have your BCA table written. That's just because I got lazy. And they take up a lot of space to print them. Not as much space when you just write them out. So you can write in your BCA table yourself. Okay, 5 molecules of methane reacting with 50 molecules of oxygen to form water and carbon dioxide. 5 molecules of methane, 5 molecules here, 50 molecules of oxygen, 50 right there, to form water and carbon dioxide. But before the reaction occurs, right, before we do this combustion reaction, we haven't made any product yet, so there's none. Okay, we do our division next. 5 divided by 1 gives me 5, and 50 divided by 2 gives me 25. 5 is way smaller. That's my smaller number, so I'm going to pull that up here. And I'm going to multiply that 5 by each of my coefficients in my chemical equation. 5 times 1 gives me 5 molecules spent. 5 times 2, I'm only going to use 10 of my oxygen molecules. And I'm going to make 10 molecules of water. 5 times 2 is 10. Remember, I'm running the reaction 5 times. I'm doing the reaction, making the recipe 5 times. Each time I make the recipe, I make 2 water molecules. So if I'm running this 5 times, then I'm gonna make 10 water molecules. I'm also gonna make 5 carbon dioxides. 5 molecules of carbon dioxide. Okay, subtraction and addition. 0 molecules, 40 molecules, 10 molecules, 5 molecules. This says specifically to box the number of water molecules that we made. That's right there. And then label the excess and limiting reactants. Our excess is going to be the one that, our limiting is going to be the one that ran out. Our excess is going to be the one that we have some left over. There we go. Before you try this one, you might get stuck because you might not know which one is hydrazine. That's hydrazine, the N2H4, and H2O2, that's your hydrogen peroxide. Cool. Now you can do this one. Again, write out the blanks. It helps to write your blanks first because it keeps your work a little bit more organized rather than just stacking numbers on top of each other. 19 molecules of hydrazine, I'm going to put a 19 right there, react with 32 molecules of hydrogen peroxide. I haven't made any product yet. Do my division, get 19 and 16. 16 is a smaller number, so I'm going to pull that one in front of my chemical equation and distribute the 16 to each of my coefficients. 16 times 1 is going to give me 16. So I'm going to spend 16 of my hydrazine molecules. 16 times 2 is 32. So I'm going to spend all 32 of my hydrogen peroxide molecules. I'm going to make 16 nitrogens, and 16 times 4 is 64 molecules of H2O. Okay, I can do my subtraction here. In my addition, to figure out that I made 16 nitrogen molecules. As you know, that's our limiting because it went to 0 and we ran out of it. It's limiting how much product we can make. And our hydrazine is our excess because we have some left over. And if we had more hydrogen peroxide, right, we could make some more product. because we have some extra hydrazine. Alrighty, that is the end of the packet. I hope that was helpful. If not, if you still have questions, please come see me because we are quizzing on this on Friday. Alrighty, I'll get this posted tonight. See ya.